And we're off. Hi.
Hi.
Oh, that was fun. Introduce yourself to them. And
That's me.
Yeah. Daniel.
I'm Daniel.
Okay, what do you do?
I speak English, and sometimes with a French accent, so they recognize them from here. I'm a security nerd in the Spring team. I contribute to Spring Security, and I also do platform stuff with Broadcom, VMware, Tanzu. And you are?
So Daniel here is the person that and again, you live here in France.
Yes.
And I don't, sadly.
Yes.
I live 9 hours time zone away.
Most of the year, yeah.
Yeah, and yet somehow you're the person I talk to almost whenever I have a bug in my security code. I need your help. I know who to reach for, and it's very bad for him. It's very good for me. So my hope is today you're going to teach them so that they don't ask me, so that I don't then have to ask you. You know?
Perfect.
Right. That's
we'll
the
do
goal.
that.
Right. My name is Josh. I work on the Spring team. We have to get a selfie.
Right.
Okay. Let's do. Can we do a selfie?
If you don't want, cover your face.
Yeah. Just
with the DevOps badge.
Yeah. Just pretend like you're happy. You know, imagine the music is still playing, you know? That was the highlight of today's session. Okay, actually, hold on. Wait a minute. Pretend like you're happy. 1, 2, 3.
Security.
Oh, he said security. All right. All right, I'm going to sit right here and watch.
Okay.
Go for it. This is the important stuff. Pay attention. There's going to be a test that I'm going to administer at the end.
And you get Josh points.
I hope you brought your pencils.
Yes. Right, WebAuthN passkeys. Who in the audience is familiar with passkeys? Who knows what passkeys or WebAuthN are?
Oh my God.
20%? 20%? Yeah, he knows since 2 days ago.
Yeah, 2 days ago.
All right. So passkeys are great. I'm going to show you what it looks like. So they're cool. They're not great. So I use them all the time, and they allow me to log in, for example, to GitHub. So here's GitHub, sign in, right? And so in here, I could put my credentials, whatever. And if I do this, I have 2FA, so I need to put, the authenticator thing or whatever. It's a bit of an annoyance. Instead, what I can do is click on this thing, sign in with a passkey, right? And on the right, you can see my hand. Ooh, hello. And you can see I have a touchID sensor here that uses my thumbprint or fingerprint to log me into GitHub, right? So that's one way of doing it. And so they allow you to log in easily and fast with a bunch of different ways. So this is a way. I also have this. This is a Yubikey.
Ooh.
Right? And click here. And so if you steal my Yubikey, you still need to know my PIN. I have to touch it again. You still need to know my PIN to be able to log in. If you steal my laptop, you still need to steal my finger to log in. And the last one is the best, it's the easiest to steal. I can sign in on your laptop using my Yubikey, but also sign in with a nearby device, right? iPhone, iPad, or Android. And it gives me a QR code. So we're going to do this, right? Sign in with a passkey. And can we still see here? Yes. And they connect together via Bluetooth. Yep, there we go. And do I want to sign in? Yes. Continue. With my phone, I'm not touching my laptop. Ooh, hello, Josh. Ooh. Hi. And you log in, right? So these are what passkeys allow you to do. So before we get into how it works, a few words. So this talk talks about WebAuthN. It's a spec from the W3C. So, these fine folks that do these kind of things, WebAuthN 3, right? Like this nifty little 250 pages of madness, right?
Lightweight as specs go.
He printed that out and read it, right?
No.
You have? No, okay.
No.
So that's the spec for putting the JavaScript in your browser that allows you to call these devices, these authenticators, and log in. An authenticator, which I just mentioned, is the device. It's the thing that does the crypto for you for logging in. And so it can be hardware, like my Yubikey, or it can be software, like a LastPass support passkeys, for example. A passkey it's the modern brand of authenticators. So basically, it's a thing the browser can say, hey, do you have any passkeys? And passkeys report and say, yep, I'm around, I can log you into this website, I know how to do that. And then sometimes you'll hear about FIDO keys. So FIDO is not dogs, it's Fast Identity Online. And it's an alliance that basically works on these specs. And it's Apple, Google, and Microsoft. They want you to be able to log in online fast and easily without a password and without a password manager, which is kind of a hack.
And when was the last time all these companies agreed on anything? They can't even agree on the color of text messages, right? Like, it's amazing that this is all, like, it's already a standard, it's already agreed on,
Right.
and it's already being rolled out, you know?
And so we have this WebAuthN standard, which is the browser standard, and the CTAP spec, which is the one for the physical devices. So how your physical devices respond to the browser saying, give me some credentials. So how does that work? As I alluded to earlier, it does cryptography, and it's asymmetric cryptography with a public key and a private key. Does everybody in the room know how asymmetric cryptography works? Does anybody need?
Yeah, of course, but just for them, you might want to explain it.
All right, let's do it short. So the idea of public-private key cryptography is the user here, Alice. She generates a private key and a public key. She keeps the private key private, and she distributes the public key for the rest of the world. And using that, then she can authenticate. She can say, prove that she owns the private key, prove she is who she says she is. So for example, she wants to prove that some content is produced by her. She's going to take that content, take the bytes, sign them using cryptography, using whichever algorithm she chooses, and then produce a signature, some bytes, with her private key. And then she publishes the content along with the signature, and the public, so the browser, websites, other people, can verify that the content was actually signed by the private key using the public key. If an attacker tries to impersonate Alice, they will generate a bogus signature, or a signature with the wrong key, and it will not match the public key. So we will know that this was not produced by Alice, or at least not Alice's private key that we have the public key for, right? So basically, this is what happens with the browser. The authenticator will generate and store a private key and give a public key to the browser, which you will then store in your server. Two phases to this login mechanism. There's the registration phase, or registration ceremony, as they call it in the spec, which is basically, yeah, right. It's not a protocol. It's a ceremony because a human gets in the loop and bows to the machine. So you generate on your device. So
I don't think that shouldn't be allowed. Like, if that works in that context, then I think we should be allowed to use the word ceremony for everything that's boring. Like, imagine going to the bathroom.
Well, you can
That's
go
your
onto the W3C mailing list and get into a heated argument about bathrooms and ceremonies if you want. But
no. If there's one thing I've learned, it's that you don't argue with the W3C nerds.
So that's the moment where you register. I'm going to say, I want to log in with my FaceID, with my Yubikey, whatever. And so generate a private key that's stored either on device or in iCloud or whatever. And then I share the public key with the website. And the website or the server links the public key to my identity. And then the second phase is when I use the private key to prove that it's me, which is verified by the public key on the server, right? And so, as we say, the fine folks of the security as the W3C put it very nice. This is one example of the diagrams. Since it's very, very easy to understand, I'm going to go really fast. No, I'm going to give you this one instead. So the flow, what happens is you generate a random challenge on the server. Why do you do this? So that it's signed, and then the server knows that it's not an old thing that's been generated 6 months ago that's replayed. So your server generates a challenge, gives that to your front end. The front end calls credentials create with the challenge, or credentials.get if you're authenticating. And this triggers the authenticator. And the authenticator will prompt to verify. So two things, either it wants to verify that it's actually you and do your password or biometrics, or maybe it's just fine with you being present. So with these, you have to be at your computer and you have to click on a thing so that the website cannot try and attack your authenticator and send 5,000 messages. You click, you verify your identity. The authenticator creates a private key, stores it, and then returns the public key to the browser. And then in your browser code, you take that public key, you take the signature of the challenge, and then you send that to the server. The server verifies the signature and then saves the public key. And then for authentication, it's basically the same. The same thing happens, except you're not creating a private key, you're reusing a private key that was existing for this website. Right? Okay. All right, enough talking. Let's code, let's do that. Before we get into the code, I have one last slide. Cute kitties. Now, because I have one more slide after, W3C again. So, nice, nice. All right. So remember this and get into the code. So we're going to start from a Spring Boot app that I have already. Let's boot it up. And this app doesn't have passkeys yet, but it already has passwordless login. So I can log into this app without a password. Can you guess how I can do this? Yeah?
Does it start with an O?
No, it doesn't start with an O.
Okay.
It's not OAuth, it's not OpenID. This has existed for like decades. And it's used in other flows. For example, when you reset a password.
Oh, OTP?
No, not an OTP. Email. Email, a magic link. Right? I can when I try to log in, I can generate a link for you and send you that by email, and then you will be able to log in. So, right, so Daniel, I'm going to create my account with a totally real email, daniel@example.com. There we go. And then when I try to log in, daniel@example.com, click login. Did you hear that? And so I get a totally real email, and I click on it, and it opens a new browser, and I'm logged in as Daniel. So you can already do passwordless logins today, but it requires the email, so there's a bunch of a bit of a dance, and it's annoying. So what we want is passkeys. Now we want to register passkeys here. So in our code for this thing, this is the account page. Basically, we have the infrastructure so that when I click, it says you clicked on registered passkey with a given name. So if I do foobar here, click register, I got a pop-up. So I'm ready to write Josh's second favorite language, JavaScript. And so in here, I could try and do it by heart and memorize what I'm supposed to do, but that's not how we code in real life. How we code in real life is we go to we go to the spec, right? Because we're security people. So let's do WebAuthN 3, this one. And the spec starts, it's unfriendly, except the beginning, which starts with some samples, registration. Okay, so we can click on that one, and it will give us the same as Stack Overflow, something I can copy and paste, and start with that. So start here, and I'm going to paste here. Here we go. So it starts with, does your browser support passkeys? Yes or no? So here I'm just going to put a comment, don't use Internet Explorer 8, please. Scream. Right. And so instead, we're going to use a browser that supports that, which is every modern browser. So Safari, Chrome, Firefox all support this.
Edge.
Edge, which is Chromium. Yeah, you're right. Sorry,
Opera?
Windows people. Opera supports it, yes.
Conquer?
What? No. All right. So public key, public key, it's a horrible name for this because it's not a public key. It's the creation options we want to create. And so it starts with a challenge. And of course, this being security people, they like bytes. So these are like unsigned integers. Instead, I'm a human. I like strings. So I'm going to be using a string. And so it has this constructor thing. So C, char, code, at. I'm basically taking an ASCII string and then turning it into unsigned ints. And so we need a challenge here. The challenge I will generate on the server. Since this is timeleaf, I can use this notation here to put in my JavaScript. And so in my controller, I need to add this to the model. Model add attribute. And call it challenge, right? And we can say this is registration dash, and I'm going to put some UID so that it's random, right? Okay, and I will want to validate this later. When the user sends me their public key, I want to validate they use the right challenge, so I'm going to store it in the session with the magic sessions attribute challenge. Right? So when I put something in the model that's called challenge, it ends up in my session. I don't really care how, Spring does it for me. Okay. So we have a challenge, fine. Then there's details about the relying party, which is the website that I'm trying to authenticate against. Here, this is the WebAuthN demo, so it's readable. It also has an ID, and the ID must match the domain in which I'm doing the authentication with. So if I do like example.com here, it's not going to work. The browser is going to say it doesn't match. If you don't specify it, the browser will infer it from the URL. Then details about the user, because on my device, I don't know if you noticed, but it told me, do you want to log in as Carlan on GitHub? So this is how you tell the authenticator who you are, or who the user is. And so in here, we're going to put, let's say, their ID. There's no user ID. There's an email, so it's going to put the email. I'm going to put the email here as well. And then maybe this display name, we put the name, username. OK, cool. And then some crypto stuff that's really easy to understand, right? If you want to use ES256, you should use alg -7, obviously, right? And what's pop quiz? What's alg -257?
I know, but you know.
Fair enough, right? So this is, you know, there's a spec for that. Usually, just
I'm not going to tell you.
Yeah, right. Just use whatever the spec tells you. If you don't put anything, it will put same default values. And then some options. So does your authenticator require user verification? So does it require biometrics to know that it's actually me, or does it discourage it, right? Or required, or preferred? If I can do biometrics or a PIN, ask for one. If I can't, then let the user authenticate with that. You can also here you can say, oh, I want the authenticator to be one of these. I want a removable thing, or I want something that's embedded in the device. Then timeout. So you remember when we went to GitHub and I said sign in, a pop-up showed up. This is a timeout for the pop-up. So if you put it too short, the user will not have time to go and run to their drawers and like look for USB keys and find the right one and then plug it back in. So you have to leave a little bit of time. For a demo, we'll leave 1 minute for the pop-up. This is fine. And this exclude credentials is for avoiding re-registering the same credential. It's fine for a demo. We can re-register this credential. I'll delete it in the end. OK. So we have all the options. And now we can call create, right, with these options. And when it's done, either we get a success or we get a failure. So in the failure, I'm going to just put an alert. Maybe, I don't know, oops, something went wrong. And we can see what the error looks like. And in case of a success, I can log what this looks like. And I can also prepare what I'm going to send to the server. So there's going to be a JSON string, because I can read JSON. And so there's going to be credentials, which is the thing the authenticator created for me, this new credential info. And I also want to give it a name. So remember in the site here, not this one, here, there's a label. So I can set the label so that the user can know which keys are registered. So we're going to call it name, right? And we're going to log it as well so we can see what it looks like. Payload. OK. Amazing. All right. So if I do this, if I close the private ones, I make this bigger. Well, when we refresh here, this is a test, right? Click register, and the pop-up comes in. And so I could do with my touchID, but I'm going to do a thing that uses only a click. So you can see here my keys are blinking. They're waiting for me to do something. I can click, and well, everything goes away because it's just a console log, right? So here, from now on, you're going to trust me that I click these things. So here, there's the credentials that are created. In the credentials, there's basically one important piece of data, which is the ID of the key, and then the attestation. The attestation is a very simple thing that's here, right? Very simple W3C standard. Basically, the important thing is that a credential is created on the device. It has an ID, and there's a public key, right? And so this is what we're going to send. Instead of trying to parse all of this, which is several layers of compression or encoding, we're going to send the entire payload, the entire attestation object to the server, and let the server store that and use that to extract the public key and verify the signature. So we do this now. We're going to send this to the server, fetch, and in here, passkey register. We're registering a passkey. So I prepared the endpoint. It doesn't do much. Method, we're going to post, and then headers. This is fetch API, so I need to add the header. So Spring can easily decode application JSON? JSON? How do you say it? And then body payload, right? Send that. This returns a promise, so I can return this. And then either it works or it fails. And if it works, I get a response. This response has a redirect URL in it. So I'm going to redirect to whatever the redirect URL is. OK? So decide how we want the keys to be generated, send them to the server, and then follow the redirect. So on the server, in the controller responsible for handling this, we have a register endpoint here. So this is where we're sending data to. And so in here, there's several pieces of information we need. We need these credentials, of course. We need the user that's logged in, because we want to associate the public key with the user. So we do that with Spring Security. Authenticated principal gives me a user. And then we need the challenge to verify that the challenge is valid. So session attribute challenge, I can't type challenge, string challenge, right? And then there's this session status that allows me to clear the session, to remove the challenge from the session. And so in here, I should take this object, read it, store it. I'm going to spare that. We'll do the interesting part manually after. So we're going to save the authenticator with the credentials and with the challenge. I think that's it, right? Yeah, and that's it. So basically, this just takes the bytes and puts them in the database, and then validates that the challenge is correct. So recompile this. All right, move away. Oop, there we go. And so the key I am registering, the brand is called Thetis here. So I'm going to click register, continue, and then click. And then hopefully, right, it shows up here. So now it's saved to the database. We've done the registration, so we can do the interesting bit now, which is the validation of the key. So now on the landing page, on the login page, I have the same thing, right? There's a button. When I click on it, it shows me an alert, right? Same thing. And so we want to call the authenticator to generate a signature for us. So again, you go to Stack Overflow or to the spec, whatever is your jazz. I recommend the spec. So again, take these. See, it's much smaller. It's nicer. OK, cool. So again, not IE8, please. Credential ID, don't care. We'll see why. And then we have some options here. So again, a challenge. Here, the challenge is super important. In the registration, it's debatable. It depends on your use case. In here, if you didn't have this challenge, and you decided to sign whatever, then someone could intercept the request, store it, and then use it at a later time to log in. Whereas here, the challenge has been generated by the server. It's linked to my anonymous session. And so when I send some signature, the server can verify the challenge that I'm signing is actually something that's fresh, that's been generated a few seconds ago or something. Timeout. And then there's this allow credentials. So allow credentials is if we know who the user who's trying to log in is, for example, in the case of a second factor, then we can say, oh, yeah, we know we have a Yubikey for you, so we're going to make the Yubikey blank and only the Yubikey, or only FaceID, right? In this case, what we're doing here, it's not second factor. It's doing both factors at once. So we don't know in advance who the user is, and so we can tell them, well, which credentials they should use. So instead, we're going to let the browser ask any authenticator that are around, A, can you log this person in? And same thing, so you're going to call credentials, and this time get, and you get a signed assertion or an error. So the sign assertion, again, we're going to send that to the server. Passkey login, right? A method, post, headers again, because JavaScript, content type is application JSON. And then the body is JSON.stringify of the assertion here, right? Okay, and we return this here. Return, and we redirect. Once the login has been successfully completed, we are going to redirect. So in here, you should be handling gracefully the failure cases. So what if I use a wrong authenticator? What if the signature is wrong, etc. In here, I'm going to assume that it's going to work. So I'm just doing this. It will do nasty things if it fails. Okay. And then on the server, so that means we need this challenge on the page. So in here, we're going to add the challenge, the same as what we did. So when we generate the landing page, we create the challenge, verification, sure. And then the server, when we try to log in here, in login, we're going to get a few things. So we're going to get the credentials with the signature. We're going to get the session attribute, the challenge. Challenge. Ooh, I typed it right. Challenge, right? And then the session status, which you should be using to say, hey, empty the session, remove the challenge from here. And so before we do actual verification, I am going to print out the credentials on the server so we can see what we're actually validating. So remove this, poop, this one. Cool, log in with passkey. And then here I click, and something happens on the server in here. And so we get the credentials. So in the credentials, there is this client data JSON and then the signature. Client data JSON is basically the authenticator producing, like showing you what it signed. So it said, I signed this, so we can decode it, this, took. Maybe that's too small. And then maybe JQ for formatting, right? So this was produced on this website. This challenge was used. Again, this is base64 encoded, but we could look at it. It's going to say verification, blah, blah, blah. Here, right? So this is what's signed. The signature is here. And I can't decode it because it's just bytes that are base64 encoded. So now we need to validate those before logging the user in. So our authenticator service will do authenticate. We're going to create a new method. And we're going to authenticate with the credentials and with the challenge. And hopefully, if that works, we get a user, and then we can log the user in. Log in service, log in the user, right? So what do we do in authenticate? There we go. Cool. So the credentials, maybe they're actually here. The credential has an ID. This is the ID of the private key I used to sign the message. So with this, the public key has been stored. I can retrieve the public key from my repository. So find by ID, credentials ID. And so this thing that I retrieve is the public key along with the user. So if everything is fine, in the end, what I will do is authenticator, this is an optional, and return the user, right? So if this is valid, then return the user. So how do we validate this? So to validate all of this, you would have to get this structure here, and then get the auth data. So this is binary, so you have to decode it. And in here, this is a CBOR representation, which is a compact binary object representation. And in here, you have these credentials. This is a KOSE key. It's like a HOSE key, but it's CBOR encoded. So you have to CBOR decode this, CBOR decode that, then find the right algorithm, then get the public keys. So this is madness. Like doing that manually, I tried. I cried, and I stopped. And instead, I went to the internet, and I found libraries. So we have basically two libraries that do this properly today for Java. WebAuthN 4J and Yubikey WebAuthN web server something. Yubikey WebAuthN, this one. right? So either of those are fine. And so you use that. And so they will give you primitives that you use to validate. So you're going to do WebAuthN manager. I use WebAuthN 4J. And we're going to validate an authentication request and some authentication parameters. So an authentication request is basically what the signature and what you signed. And then the authentication parameters is like, which key should I be using to validate this, right? So in here, authentication request, we have to find what we need to use. And there's a bunch of constructor with many things. So I'm going to take the simplest one. I take these. OK. And so it tells you, oops, it tells you what you need. You need credential ID, authenticator data, client data JSON, and signature. All of this is in the credentials that came in, and then the signed data. So ID, and this, they want bytes. So we're going to decode this, decode, so that we have bytes. This is their interface. So then we need authenticator data. So client response authenticator data. Then we need client data JSON. Fine, we have client data JSON. Cool, and then signature. So that's the important bit that says, hey, all of this that I showed above here, I signed it, and here's the result. The private key stays on the authenticator, only the signature moves around. And then, well, what do we verify the signature with? Basically, in here again, constructor has 2 or 3 properties. It has this server property, so it requires creating a bunch of their objects, but basically 2 important things to verify. You're going to verify that it matches the origin, so on which website the login happened, so that you're not trying to hijack credentials from another website or something. And then the challenge that came in, right? And then the attestation object, so the authenticator here. I can't type. The authenticator attestation object. So basically this whole blob, which contains the keys. So the keys here, and then you also are going to say, do I want user verification? Do I want biometrics? So false. And in here, in the sign, in the client data JSON, it will tell you, oh yeah, we set it was user verified or it wasn't. So no, I don't care that it's user verified, and that's it. So then we call validate. And so why did I cry? Because when you look at this, and deep inside this validate 3, that you have to parse this, then you call validate, and then step 1, step 2, step 5, step 9, and all of these have like their own validate of things, right? So step 18. So even they don't go all the way. The spec tells you have to go to step 25 to validate this. So you let them do the thing, do the heavy lifting. Compile now. We go here. My demo is here. And now when I do login with passkey, hopefully click. I'm logged in. Voila. So that's how it works. And how does it reject a signature that's like wrong or a challenge, right? So if I put some challenge, I am a pirate. Ho, ho, ho. Right? So in here, right, it will validate that challenge. Boop. And I don't get logged in, and I get, an exception somewhere that I don't handle. Can't see it here, but it will tell me bad challenge or bad credentials or something like that, right? Okay? So before we move on to Josh's part, he's ready. He's making the demo compile right now.
Oh, yeah.
Some observations on this. It's cool. It makes for a cool use case, right? I could now, on the website, I can register my phone, I can register my Yubikey, my thumbprint, whatever, and I can log in with them. And it's very useful. But it's very, very complicated to wrap your head around what it works or how it works. So you should be using a library. And even like that, it's actually complicated. Like you have to select the right constructors for these weird things. We have skipped some security stuff. So the library here, it's very nice, but it tells you in the README somewhere, don't forget to increment the signature count if blah, blah, blah. So complicated. To reduce the complexity, you have to define your use case very well. So do I want 2 factors? Do I want a single login? Who is going to be using that? And then there's no skipping the hard part. You have to read how it works. Like you can't imagine this. It's just like OAuth. Like who thinks OAuth is easy here? One hand. we'll do it like four people, right? This is the same as auth. It's complicated, and in order to make it work, you actually have to learn a little bit more about. You can't just like drop, some JavaScript and hope it works. Yubikey has a great site explaining how all of this works, and so we in the Spring team we try and make this as easy as we can, at least for the default case. So this is coming in Spring Security. Not in the version that's coming next month, so not in 6.3, maybe in 6.4. There's still a lot, to be worked on, but we hope to give you this. And with that, I think, Josh, are you ready?
Yeah, I think I am. It's
all right.
Can I take your HDMI cable?
Yeah, no. You're connected already, aren't you?
Am I already connected? Oh yeah, switch over. Oh yeah.
A picture of a car.
It's
It's not working.
Oh,
it's four.
You can do it.
Again.
Hey, sweet nectar. All right, so basically, we now you understand the theory, the important stuff. But let's take a look at like practical implementation. What we're going to show you, as he just said, is super not done yet, right? This is code that we took from Rob Winch's GitHub repository. So Rob Winch is the lead of Spring Security, okay? And he's the other person that, if he could block me on Slack, probably would, right? It's because I don't understand 90% of this stuff. I just know that he does, and that's enough. And I live my life trying to be led by his guiding principles, right? My goal is to see him and tell him what I did with security in the last month, and not have him like crush a can in his hand in disgust, something like that. So this is the project he's been working on, and we've got the sample code. We're going to go ahead and I have another branch of this code, which is where do we put that over here, right? GitHub.com, and then we go to repositories, and there it's in this repository. This is the code that we're going to look at today, which in turn has his code plus our little demo here, okay? That Daniel here kind of pulled together, and then we upgraded a little bit. So not yet done, but it does demonstrate the happy path quite well, okay? So let's go ahead and take a look at it. We're going to go ahead and go to start.spring.io, my second favorite place on the internet, obviously. We're going to call this beautiful passkeys, all right? I'm going to use Java 21. I'm going to use Maven because right now it's a little weird with Gradle and Java 22. And then I need the web support, right? Web, here we go. Good, hit generate, open that up in the IDE. Here we are.
So in the future, you will be adding security, but
Right.
it's not baked in yet.
Not yet. All right, so a couple things. This is just a regular Spring Security application. I need to pull in Spring Security, obviously, so I've got a locally built version of that library in my local machine. So we're going to call this Spring Security WebAuthN. I'm using the rwinch branch, right? The qualified version of the code. So this is not on Maven Central. It's locally installed, but you can try it at home.
Can you make it a little bit bigger?
Yes. Zoom. How's that?
Yeah.
Everybody in the back can see that?
They have small screens on the back.
They do? Okay, well, in that case, I'll make it bigger. There we go. How's that in the back? All right, so good. So first things first, I need to describe some users, right? This is an application that has some users, right? Obviously, in Spring Security, you do that in terms of user details manager, right? So you do user details. Oh, I have to re-import the code here. Command-Shift-I. Okay, user details service. There we go. Good. And I'm going to return a new in-memory user details manager. And this is just me hard coding some users, which is already not great. Already, you can see I'm doing it wrong. But okay, let's just say we have a user. Then we need a password. And friends, it's very important to remember Rob Winch in all of this. Okay. What I would normally do on stage is I would just do this. I would do dot. With default password encoder. And what that does is it uses the no-op plain text password encoder. And then that in turn caused a situation that I only discovered later, which is I would do that here in France maybe, right? Or somewhere else in the world. And then in Kansas, in the United States, for reasons he'll never understand, for reasons that he could never understand, Rob Winch would become sad. And he wouldn't know why. It's called cryptonic entanglement, right? So I would do bad cryptography here, and he would become sad over there. And so the goal is to avoid sad Rob Winch. This is sad Rob Winch, okay? Don't do this to him. Look at him, he's just so unhappy. So let's fix the code a little bit. I'm gonna make this a little bit better. We're gonna use .password. We're gonna use, username, JLong, and then I need a password. And the password, well, I'm gonna just tell everybody. So it's a Spring encode password, right? And I'm gonna do, the password is just gonna be PW, okay? And that's gonna encode it for me using bcrypt, which is the default encoder, the encrypt, that you get. Get rid of that, I need that period. And then the roles will be user, okay? And then I've got a build. All right, so now I've got my, I've got one user in the system, okay? Now I need to actually do the hard part, right? Which is the WebAuthN part. And when I say hard, we're still not gonna do JavaScript, so it's not that hard, I saw it once said on the internet, and it's true. JavaScript is to Java as car is to carpet. It's a completely different thing. Okay, so here we go. Bean, we've got that. We are gonna create a default security, security filter chain, right? Here we go. Where did it go?
Type it, sometimes intelligent.
There you go. Here we go. It's got it. All right, and actually that's a default. Okay, very good.
The interface is fine.
Yeah. There's the build. And so the first thing first is we're gonna say we want form login because we have to, the original login. Then we want to authorize some requests. What requests? Well, we don't need to do the login, so we just do any request is going to be authenticated, right?
Yes.
Okay. And then we do the with. And here, friends, this is the only WebAuthN specific bit, right? I'm going to pass that in. It's going to give me a builder context. There, I need to specify some of the stuff you saw him specifying there in JavaScript, including the origin, so localhost 8080, the RPID, which is localhost for reasons, and the RP name, which I'm just going to call Beautiful Passkeys, okay? All right, and that looks basically okay. What's wrong with this up here?
Exceptions.
Oh, exceptions. Okay, here we go. Yeah, throws exception. Okay, very good. So there's my you can, I spaced it weirdly, but it's actually not so scary if you think about what I'm doing here. There you go. That's a little bit better. It's 3 interesting lines or 3 different stanzas. Okay. All right. So I think that's it.
Yeah, and in the future, it won't be with. It would be
like
.passkeys.
It'll be like .passkeys, a custom builder off the context object there. Okay. So let's go ahead and restart that. Consider defining HTTP secure. Oh, you know what? I forgot to do the old web stuff, didn't I? No, I got it right there.
Now you have it. Enable web security.
Yeah. Enable web security. I wonder, did I have to re-import this?
Maybe.
Okay. We got this dependency here. We got Spring Boot Starter Web. Take 3. Oh, okay, this. My security chain, please work. Okay. All right, good. That seems happier. Great. So that's up and running. I'm going to go to the browser here, localhost 8080. Okay. It's going to ask me to log in one time. What was the password? PW. Thank you. Sign in. Good. Now I can register a passkey. It's asking me to, Devox France. Okay. Register. And there we go. Sign. Okay. There we go. It's now got that. I go to log out. Okay, voila. I'm going to log out again. And now I'm going to sign in with a passkey. This time, just straight with the thumbprint there. Ta-da! I'm authenticated. I'm logged in. It's great. Thank you. So he's happy now. We did it. So this is a rare, wonderful thing where I get the best security while also getting the best ease of use. It's very rare that security is associated with the easiest outcome, but this is actually both easier and more secure. And obviously, if I wanted this to go, to production, I would just kick off a GraalVM native compilation, native compile. We'll let that do its thing in the background, and that'll do its thing. It's like 30 seconds, which is fine because we have 41 seconds.
So we can show the links to
there you go.
The stuff we've been showing. Demo without Spring Security, and then Rob's Spring Security branch, which has more explanations on how you can run this yourself without doing the install. And then the QR code is a security hack. No, it's the feedback form for devox. And if you have questions while this is compiling,
Yeah. Thank you, everybody. By the- Who learned something new? Who learned something new? Because I did, that's for sure. I mean, oh, good. Okay. Who had fun? Okay, very good. I'm glad to hear it. Wonderful. Please vote. They won't invite us back. Come on, help us out. All right. Well, thank you.
thank you, everyone.
Bravo. Boom.